Hey, what's up guys? Welcome to this channel Turbo Electronics Experiments. This is my second video I think in this channel, and this video is going to be very much important for all those people who have little more interest, like me, little more interest on making projects on electronics. So projects that I am going to talk about is not IT based projects or not the projects that say software engineer generally do. You may heard these words: app development, web development, everything, Python programming, C programming, blah blah blah. So here the project means the electronics based projects who are going to build their own gadgets, who are going to innovate some new things. Okay, the IoT based projects are also included in this projects domain. Okay, so what reputed industry, or what you should follow, what we all should follow to build your own electronics based gadgets or projects? What are the steps that an industry follows? I'm going to share all the 7 steps. There are 7 steps, yes, 7 steps to all of you. So listen to these steps carefully, and I have learned all these steps from my superior or from my teacher. So I'm going to give you all the tips so that you don't be harassed after building your own projects and after seeing that it's malfunctioning. Yeah, it happens, and I used to do that. Most of the cases, what I used to do, after identifying components, I went to market. I used to go to market, and then I used to assemble my project. After assembling, I used to see generally what happens. Most of the cases I used to see that my circuit is malfunctioning, and then what I generally used to do, I used to quit them. Either I used to quit them, or I used to make some another projects, or make this project from first. So don't do that. If you want to avoid these harassments or these disgusting steps, that means after malfunctioning any circuits, you are just getting, oh no, it's not for me. If you don't want to tell this word, it's not for me, so please watch this video from first to last. I am going to give you all the 7 tips which are going to be very much important for all of you. Even the first and second tips are very much important. Listen to all these tips carefully. So, without wasting any more time, let's start our video. What you have to do, your first step is identify the components along with the model number. Yeah guys, identify the components along with the model number. I'm giving you an example. I want to build a amplifier, BJT based amplifier. BJT based means NPN transistors, bipolar junction transistor based amplifiers. What I have to do, I assume that I don't know anything about electronics. I only know the circuit. Yeah, there is a circuit, and there is a collector, there is an emitter, there is a base. I have to ground emitter, and I have to give input base through a capacitor, and I will get output from the collector through a capacitor. I just know the circuit, and I have no idea what's the component required, what values of the capacitors are required, don't know anything. So for that, you have to, that's the first step, that's your first step to jump into your project, that is identify your component along with the model number. Like that, I am going to build my own amplifier. I want a NPN BJT. What I generally do, I go to Google and I search NPN BJT model numbers, and Google knows everything. Google will show thousands of models of NPN transistors that can be used as an amplifier. and you will get again harassed. There are 1,000 types of components. What should I buy now? What should I require? So first of all, you should understand your requirement. That is, you have to specify your requirement. Something like that. I am going to give a 4.2 volt DC power supply which can deliver up to 2 ampere, and I want to attach a 25 watt speaker with this amplifier. So my input power is 5 volt into 2 ampere, that is 10 watt, and output power is 25 watt, and I am going to give an input 5 volt 2 ampere, and I need these types of transistors which supports all these criteria. That is, that can take inputs 5 volt 2 amps, that can produce output 25 watts, even more than that, and that can provide me the maximum efficiency. It is very important factor, because when you want to search these types of transistors or this type of BJT which are going to fill up all these criteria, then you will find that there are also 100 kinds of models. The efficiency of some transistors are 80 to 85%, some are 90 to 95%. 100% efficiency is not possible. Maximum 95% you may search. So you have to find maximum efficiency and that component which are going to fill up all your criteria. It's not for transistors, it may be for ICs also. I am going to give you an example that CA741 and 358, LM358, both are the ICs of op-amp, operational amplifiers. But you have to make sure that what you are going to build with these ICs. You are going to build an amplifier, then go for CA741. If you are using this op-amp as an comparator or just as a blinking circuit, then go for LM358. Okay, so you have to make sure that what the exact model number, exact model of exact component of what exact model you need. Identify that component. After identifying, the second step is just tabulate it. Tabulate it along with price. Yep. This point is very much important, and upon this point your total project price depends. I am going to share with you many kinds of problems upon this price point. Okay. So after making list, you have tabulate the prices of each and every components and which components are required in how much quantity, that you should mention also. So after mentioning the quantity and prices and calculating the whole prices, we have seen that your pocket is empty and your pocket is not sufficient to fill up all these prices. Suppose that you are going to produce a project which cost around 1,750, but your budget is 1,200, sorry. So your budget is 1,200, but it's 1,750. What you should do? What maximum people generally do is, yeah, my budget is 500 rupees less. So now I will buy some components and later I will buy another's. After that, what happens? Suppose there are 20 components that you have to buy and you have bought 15 components and rest of the 5 components doesn't support your budget. So you think that, yeah, next month I will buy the rest of the 5 components. The next month never comes. Yeah, the next month never comes because the energy goes down. Okay, so next month never comes. So don't do that. What you have to do, you have to, when you are seeing that you are watching that your budget is not supporting the whole prices of the component, just try to search alternate of some components. First of all, make a list which components are extremely necessary. That means without those components you can't make your project, make this gadget. Okay, so sort out those list, and in another side sort out those which components are not required right now and you can make its alternative, something like that. I have given one example you, that I am going to build a op-amp based blinking circuit. So for an op-amp based blinking circuit I need 2 op-amp. I have bought CA741 op-amp which costs around 10 rupees. Okay, and I have to buy 2 because one CA741 op-amp, inside one CA741 op-amp there are 1 op-amp at least. But in case of LM358 op-amp IC, there are 2 op-amps, but both of them works as a comparator. Okay, so I have to go with LM358 IC, which cost around 8 rupees, because I need 2 op-amps. Okay, and for 2 op-amps CA741 I need 2 CA741s which cost around 10 into 2, that is equal to 20 rupees. But I can do the same work with LM358 IC because there are 2 op-amps inside this one IC. 2 op-amps have already been fabricated in one IC. So I have to buy only one, that costs around 8 rupees and I can save 12 rupees. In this way, you have to choose which components are extremely necessary, which components are not so much necessary right now. And for extremely necessary components, you have to select some alternates which costs less than that. And after that, if you don't still your budget is less, then wait. But don't go to buy right now. Don't go to buy right now. Wait. After some days when your budget will increase, then go to buy. No problem. But don't do that. Today I will buy something, buy some of these components. In next month I will buy some of these components. That I have already told. Next month will not come. Point number 3. Point number 3 is, after everything is ready, your list is ready, your price list is ready, your idea is ready. After everything ready, just go to market and buy components. Okay. Here, an important tip I am going to share with you again: don't buy any electronics based component online. Okay, there are 2 reasons for that. If you go market, suppose that's first time you are going to market to buy some components, right? So if you are going to market for the first time and you are going to buy some components, you will face many kinds of problems, something like that. I have even recall my first day when I went to Chandni market to buy one 3.7 volt battery. I have just entered a random shop and told that I need a lithium battery. Even I don't have any idea what types of lithium batteries are there and what is the exact model number. I don't have any idea. So I just went to a random shop, which was a computer shop even, I remember. After entering in that shop, I just told the seller that I want a lithium-ion battery. Well, after that, the seller asked me for which computer. This was a laptop battery, and I mentioned it that it was laptop batteries because 18650 lithium-ion batteries are basically known as laptop batteries in commercial market. So I already told a laptop battery. Okay, and after that, what happens? I will tell you guys. And there was 500 rupees in my pocket. The seller went in the storeroom of that shop, and brought to one hand packets. Yeah, the packet length was about 1 feet length packet, and he placed that packet in front of me. And cost, then I asked what is the cost. I thought that inside these packets there will be up to 100 18650 batteries. That what I have generally saw in online market. Okay, so after placing this packet, I asked about the price to the seller, and the seller, yeah, this price is around 5,000. What? 5,000? Are you joking? Then the seller obviously told me it is for HP 14-inch laptop. It says A-class lithium-ion batteries. Then I came out of the shop because I don't know what will happen. So that's why you shouldn't buy your electronic component in online. You should go to market. What happens after doing same mistakes, after asking randomly people which shop is where, then you will recognize the whole market, and you will have some idea. Okay, you will have some idea that the components that you know, the model number. Suppose that this 18650 lithium-ion battery. If you go in battery shop where these batteries are available, and you asked for this 18650 lithium-ion batteries, then what happens? First of all, they won't understand. Most of the sellers or most of the shopkeepers don't understand what is 18650 is. You should tell them that, yeah, I need lithium-ion cell, 3.7 volt lithium-ion cell, of which capacity you should also mention that. So in this way, you will have some ideas that how the shopkeepers knows these components, and what are the alternate names, what are the nomenclature of these all kinds of components to the market shopkeepers. Okay, you will have these types of ideas. Okay, so that's why you should go to market. And second reason that you should not buy your components online is its price. Guys, I have a very bad experience that I am going to share with you. That is, first of all, at first day, I remember at first day when I went to buy a Bluetooth audio module in the market. Then I saw its price in the online. It was 250 rupees. So my budget was so much tight that I just went shop with 300 rupees, within which the 50 rupees was for my ups and downs, was my delivery price, my journey price. Okay, so I just went to market with 300 rupees, and after going to market, I have seen that this same module cost in the offline market just 50 rupees, not 250 rupees, just 50 rupees. And I was astonished. What? Yeah, so it's in online it's cost around 250 rupees, and in offline it's cost around only 50 rupees, and some are 60 rupees also. But can you imagine the price difference? It's about one-fifth of the price of the online. So please don't try to buy components in online. Always go for market. It will be better for you. You will learn something from this market and from the shopkeepers also. Okay, that's one, number 3. Number 4, suppose that you have bought some components. After buying components and after coming home, number 4, what you have to do is don't touch the physical components at first. Design the circuit on the simulator. Yeah, simulator means PC simulator. And for simulator, you may use Eagle, you may use National Instrument Multisim, you may use Proteus, etc., etc. And already I have made videos on Multisim as well. I have made a playlist. There are 2 videos basically. half an hour and 2 hours. So you may watch this video. I will give these links of the video in the high button. You may watch those videos. So always try to make your circuit in the simulator first, because I will give you the reason also. What happens before touching any physical component, before physical assembly, you all should buy the you all should design the components, design the circuit in the simulator, because after designing all the components in the simulator, you will do fault analysis instantly, live fault analysis. Okay, if you do your physical assembly at first without designing it in the simulator, then after getting fault you will be again face harassment, right? So to avoid this word harassment, this harassment is very much dangerous. So to avoid this, you should first design the circuit in the simulator, and after designing the whole circuit, you simulate this circuit as well. And after simulating, you see that this LED is not blinking. So you are checking the voltage in the simulator. You are in the simulator through multimeter. You are checking voltage there, its current voltage, and at another point, its voltage is also current. At the LED point, you see that here voltage is not reaching. So you should change some component, something like that. You fix it in the simulator. After fixing it simulator, after successful run in the simulator, you will be sure that now what's the connection I have made in the simulator is perfect. Now I can start my physical assembly. Because after editing or after debugging components in the simulator, after debugging circuits in the simulator, obviously you will be sure that your circuit design is perfect, your component choosing, the model of the component that you have chosen is also perfect. So if everything is perfect, then you can start your assembly. So number 5 is start assembly. But here again an important point, that before starting assembly, physical assembly, that means if you start after simulating in the simulator, if you start that assembly in the PCB, that you are again doing wrong. What you have to do, you have to just assembly it in your breadboard. That is a temporary assembly, and you have to buy some jumper wire as well for connecting those circuits. So in breadboard you should do your first temporary assembly. After completely, because sometimes what happens, in simulators, it is a program, right? So the simulator who have made this multi-sim simulator, Proteus simulator, is nothing but a program. So there may be some mistakes in the program also. So whatever you are seeing in the simulator may not happen in your physical world. So that's why you have to assembly the whole thing in your breadboard first, where you will be able to do your fault analysis again and again, because after soldering each and everything, it's not possible to searching fault and debugging them. So the number 5th step is assemble the whole circuit in the breadboard. That is a temporary assembly. Number 6, if it runs perfectly, after breadboard assembly, you see that you are getting your desired output, your circuit is complete now, then you can start your physical assembly on the PCB or on the Veroboard. Just soldering. You should start your soldering as well. Then again, after soldered each and every component, again you see that your LED or your output is not giving. At this step, at the 6th step, if you follow above 5 steps, at the 6 steps there is 10% chance to produce an error. But if an error is produced, that after soldering everything at 6th step, you see that your circuit is not performing well, or the LED is glowing very low brightness, or LED is not glowing itself, and the if you are using speaker, your speaker is not giving output. So how will you will start debugging? It is a very important question. How will you start debugging? Start debug from the output sections. That means from where, suppose that you have made a blinking LED circuit, you are seeing that the LED is not blinking, it is glowing constantly. Why it is not blinking? So start doing, just take a multimeter and start checking voltages from the output. That LED is not blinking. Not blinking means it should be, the voltage will appear for some second and voltage will not appear from some second. That is 5 volt 0, 5 volt 0 or 3 volt 0, 3 volt 0. It should behave something like that. What it is behaving right now. Just hold your multimeter props from LED. You have seen that there is no blinking of the voltages. That is 5 volt 0, 5 volt 0, it's not happening. So what that point is coming from? From what point that output voltage is coming from? You have seen that point is coming from IC pin number of IC, pin number 2 of the IC. So check pin number 2 at pin number 2. Yeah, you have seen that pin number 2 is not responding as well. At pin number 2 the voltage is not blinking as well. So at pin number 2 is not voltage is blinking, then go to the input section. Yeah, if pin number 2 is for what input, the pin number 2 should give an output of 5 volt 0, 5 volt 0 or 3 volt 0, 3 volt 0. For what input? Just go to the input section of the IC. In this way, you have to start from the last and come to the first. And the fault analysis will be much more easier in this way. Okay? And for where you will get fault. And after if you see that the supply voltage is okay but output is not giving, then the IC is done. Tata bye bye IC. Okay, so first, that's why I am telling you that start debugging from the output section and come to the input section. Last to first, not first to last. If you start from the first to last, then again harassment will come. Yeah. So from last to first, you should start debugging and fix your circuit. Now, the 7th step and the last step is you have completed your project. Yeah, you have fixed it. You have followed all the 6 steps that I have said previous. You have followed all the 6 steps and you have completed your assembly, physical assembly, temporary assembly, everything you have completed. Your circuit is performing well, your circuit is giving your desired output also. So what you should do the second step. In second step, number 7 is just give a suitable body, a suitable structure of this project. Don't give it that it has been assembled on a Veroboard. Just leave it. Don't do that. So always try to make a box or buy some box or give us proper structure of this project. You may use colors also. Yeah, just make a casing for it, make a structure for it. Just put your project inside of it, so that just at this step you should assume yourself that you are a boss of your company. You are going to launch a product in the market. So will you just launch the circuit of the component? When a mobile manufacturing company launch a new mobile phone, does they launch only the PCB, or they launch the whole body with glossy finish, something like advertising, glossy finish, chrome black, 50 megapixel camera, and at that time they shows their phone something like that. Their looks, the phone of the looks attracts the customers. That's what you have to do. So what you have to do after doing everything, after performing everything well, you just need to make a small enclosure or small box EVC box or whatever, to make sure that it looks well. Okay, and it can be sold in the market as well. Okay, that's what you should do. That's the number 7. Okay, so this, if you follow all these first to 7 steps, step number 1 to step number 7, then you will, as well as you will do your project perfectly, and beside it, your product that you will make will be ready to sell in the market. Yeah, I'm serious. Your product that you will make will be ready to sell in the market. Okay, so always try to follow all these steps. Okay, so hope all of you have enjoyed well. If you enjoyed this video, what you have to do, you just hit the like button. Please guys, share this video as much as possible, because as I have already told that as far as I have seen, I haven't got any kinds of video like that in YouTube. So share this video, as the people who have interest in electronics based subject as well get this video as soon as possible. Okay, so like, share and subscribe this channel, because I am going to upload some new project based video in later. So subscribe this channel as well. Thank you. Bye bye. See you in the next video. Thanks for watching.